Good morning. How's everybody doing today?
Better.
Better?
Yeah.
Fantastic.
That's right, you had a couple rough past couple days, is that right, Kylie? You're doing better?
Yeah.
On the mend?
Yeah.
Good, glad to hear about that. Yesterday, we worked on and introduced the,
Absolute.
very good, Extreme Value Theorem. Okay, Gavin was on it pretty good, right? Gavin got most of the words and concepts of it, yeah. Gavin, you've just been doing great this year.
For real?
No, really, because you really, I mean, the conversation of the
I
class.
thought he was better last year.
No, because I think you're doing great, Gavin.
Thank you. Aaron just likes to hate.
I'm a hater.
Aaron Daner.
Anyway,
It's just depression.
finding absolute maximums and minimums, and so that's exactly what Gavin was talking about. So we're going to go to what we call, we have some examples here, and then we're going to go to classwork exercise. So I'm going to just sort of review what we talked about yesterday in one of these problems, and then just kind of turn you loose to work on some things. So we have right here, what did we talk about setting up for such a thing? Something we called I called
The chart or the line? Chart.
yeah, charter line. What I call it a candidate list.
A what?
Candidate list, right? And I got a joke about that too that you might think is halfway funny.
Let's hear it.
I'll tell you. What I'll do is let me work this out first, and then I'll tell you.
I didn't work it out, man.
So the endpoints. Oh, by the way, we also know that this is going to work because we have
If they're closed. Right.
because closed, I wasn't even thinking of that, but Gavin's right, okay. Closed interval, very good. And what else?
That's all I got.
Because we're continuous
Yes.
in this interval, okay? So we know that those requirements are met, and so we put the endpoints here to our candidate test. And now, what are we looking for next?
Critical numbers?
Looking for critical numbers. Very good. So it's good to see people having paid attention in class. So that's going to be, what was that going to be, 6x minus 24? Does that look right?
Absolutely.
Looks perfect.
Okay.
Oh my God.
So we say 0 is equal to, and we're going to factor out the 6, right? So you have 6x minus 4. So what's our critical number going to be?
X equals 4.
X equals 4. And so are these all the candidates we have?
Yes.
Yeah, they're all our candidates. So let's go ahead and evaluate the candidates, shall we? So we're going to have f first of -1, and that's going to be equal to, that's going to be 1, right? So that's going to be 3 minus 24 times -1, so that's going to be plus 24, right?
Yeah.
And then minus 1, and so 3 plus 24 minus 26, right? Okay, 26. So that's 26.
Yeah.
Is that right?
Yes, that's right.
No, but it's right to be hesitant about it, to question
No, it
something.
wasn't right at all to be hesitant about it.
No, that's fine. It's fine.
I was trying to.
But I want you always to think self-critically. So now we have 3 times 4 squared. That's going to be like 3 times 16. Was that 48? And then minus 24 times 4 that's minus 96. Is that right?
Yes.
Minus 1. So that's going to be negative 48 minus 1. So that's going to be negative 49, right? And then lastly, we're going to take f of 5. And so we're going to get 3 times 5 squared. Is that going to be 75?
75.
Minus 3 times 5. That's going to be what? Minus 120? Minus 1. So that's going to be,
That's a tough one.
yeah, it's going to be negative
45?
45 minus 1, so negative 46, right?
Gavin's
So, so can we answer the question now, absolute maximum, minimum?
Yes.
So absolute maximum what's our absolute maximum?
It's 26.
26, and just to make sure where x equals negative 1, and then absolute minimum of
49, negative 49.
negative 49,
Where x equals 4.
where x equals 4.
Those two haven't participated. Multiply.
I know.
You losers.
X equals negative 1. Now, candidate test. I got to tell you about candidate test.
Oh, the joke.
Yeah, I don't know if you think it's funny. I thought it was funny.
I think
I was going through to some calculus teacher training at Carrollton at Valley Ranch. You know where that is? Out by the airport, Valley Ranch, where the Cowboys used to be before they moved to Frisco. So I was at Valley Ranch High School, and there was a calculus teacher training, and we had the guy who's the teacher, his name was Manu Barbarossa, I think it was. Anyway, he was really funny, but he was a really good teacher, and he talked about well, I had this one student that she was so great that she was really a candidate. She was really a candidate to be a daughter-in-law. That's how great. Or this guy was so great he'd be a candidate to be a son-in-law. And so what happened is I went home and I slept, got ready for the next day, and in the night I dreamed about the son-in-law candidate test and the daughter-in-law candidate test. So combining the candidate test with the son-in-law and daughter-in-law thing. You ever seen a son-in-law candidate test?
Yeah.
That's the one the kings do about the daughter. If you go through this and do this, you can have the hand of my precious daughter in marriage and eventually ascend to the throne of the kingdom.
Heirs would never have gotten married.
What did you say?
All right, you guys didn't think it was that funny, but at least you didn't boo me. So
What did you say? What did you say? It is my business.
okay, what I want you to do is go ahead and work out problem B, a similar type of problem, and see how you do on that one. Okay.
Not like the whole.
You're gonna make it more.
Yeah, this year I would like to see something cool real quick.
I would not.
Yeah, thank you.
It's not an acceptance, but that's a really good deal.
Oh, really? So it's sort of a, well, I know where that is. I had a guy had his wedding reception there. They paid a pretty penny, you know. You know what that is, the Royal Oaks Country Club?
Not exactly.
It's right by Presbyterian Hospital.
Oh, yeah.
I have no idea.
It's really good. Shoot, it's going to be December 17th.
Here. My mom pointed at you should be drinking like 8 water bottles a
They're on the
day.
list.
That's what my parents
I
say.
drink like 1.
I don't drink any. And I feel healthy.
Okay. Yeah, Carson, you mind if I tell people? Carson was invited to a prospective a reception for promising Naval Academy candidates.
Nice.
Was that it? Yeah,
Basically.
December 17th, essentially. So,
On the birthday.
That's your birthday?
Yeah.
That's your birthday too? That's awesome. Man. So you get to come right in here. So you'll be taking a final on Wednesday, and you go there Thursday the 17th. All right, so you'll have the final in this class out of the way, and well, so that'll be cool. I think that's going to be the final schedule. That is the coolest thing.
Thank you, man.
Now I got some stuff to brag about with Carson.
Attaboy, C money.
You think Carson is a good candidate?
Yeah, I think he's good. I recommended him, so I guess
Carson's gonna.
you know, if he doesn't work out, maybe they're going to come looking for me and blame me. You recommend this guy? Oh man. No, it doesn't work that way. Who knows? Mine could have been the worst recommendation he had of the bunch. Probably not.
I believe in Carson. No, you should do Carson. You should just quit.
I had another student who made it to Naval Academy once. What he did, yeah, it was over from Wilmer Hutchins, Adrian, and the program he was in is he went to a preliminary program. Like he sort of went, I don't know if it's a Marine, something or other, so he went there for a summer and then went into the Naval Academy. He wasn't ready right off day one, so he had to do a little preparatory training.
They have like the prep schools.
Yeah,
And they think, so that's basically if like your grades are good, but they want to be a little bit better before you go in some fields.
yeah,
Like,
that's right. And so the thing about it is that for him, but he's a smart kid, so he was a smart kid and a worthy candidate, but probably being intercity school and stuff like that, probably they just want a little honing in the preparation.
If they
Yeah,
offer me that, I'd definitely take it.
yeah,
Off you.
To send me to like a one-year prep school first.
Yeah.
so I have to check on Adrian, see how he's doing. So how'd the candidate test work out on this guy here?
Good.
What are your, have you finished this yet?
Number 2, B. Oh,
No.
Oh, are we supposed to be working on that the whole time?
2, yeah.
Oh, you didn't tell us that, Mr. G.
B.
Sneaky guy.
Problem B. I thought I did.
I don't think I ever did.
You were paying attention to other
If you were
stuff.
telling us about the candidate thing.
Yeah, well, that's all right.
I'm sorry, Mr. G. Oh my goodness.
See, Aaron, you are one of these guys that you're usually 100% on it. And when you're not on it sometime, it just lets us know that after all, Aaron's not perfect.
Aaron's
And that's
I'm not
good.
perfect, right?
Yeah, and that's good. That's good for me to be reminded of sometimes.
I'm not perfect. I suck.
you mean 18x squared minus 24. I mean 6 times 3 is
I think I need 6
I think you take 6x squared out of
We
it.
just have to take
6
it.
squared.
Multiply it on that.
Right?
Like, yeah, that makes sense.
If that 6 wasn't there, then you just move the 3 right there. 24x cubed.
Trying to read that, it's going to be x squared, right?
Yes, sir.
Minus 24x cubed.
That's what I got.
Squared.
So was that going to be 6x squared out of this thing?
I think so.
Mm-hmm. That's what I did.
So that's going to be 3 minus 4x.
I think so.
So we have x equals 0, right? So that's gonna be one of our criticality numbers. And then the other one's gonna be,
Dear King.
so that's gonna be 3/4, right?
Alright. Bring it back. Oh,
Okay, so those are your critical numbers we got out of this deal?
Yes.
So,
Okay.
so here 0 is the easy one, because that's your intercept, right? There.
No, I got it, Mr. G. No, 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 don't do it. No, 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 no.
Oh,
I would have had it.
Yeah, okay.
you don't need it.
I don't think he does. It's kind of hurtful.
So anyway, f prime of -1, what'd you get for that? That's gonna be 18. And that's gonna be negative, negative, so that's gonna be plus 24, right?
Wait,
Minus 1. Isn't that right?
I think he's right.
Because of -1, that's that. And then here you got a negative, negative, which is positive. So that's gonna be what, 41, something like that? Is that right, 41?
Yep.
Okay, then 3/4, now we're getting into minutiae here, aren't we?
Just like wanted to start crying.
Yeah, so this is one that I would just go ahead, I would just put this in my calculator. That is, because it's fraction minutiae, and I don't want to deal too much with fraction minutiae here. And so while somebody does that, somebody round up the 3/4 and then the 2, I'm going to kind of work that on the head. So f prime, I said it's not f of 2 is going to be 6 times, that's going to be 6 times 8, it'll be 48. And then we have negative, that's going to be 2 to the 4th, is that 16?
16, yes.
Minus 6 times 16, what is that going to be? 15, 96.
96.
96. So it's going to be minus 96, right? Because that's going to be, yeah, plus 5. So negative 48 plus 5, is that negative 43?
That's what I think.
Something like that. What did you get for the 3/4?
Who did it? No one did it, or you came in? How did your job?
I don't have my calculator. I thought
Hannah,
else can do it.
Hannah, that's your job.
Does that mean -1's wrong? 'Cause since
Yeah, one negative.
Yeah, what do you do there?
-1, you did the prime of x and not just regular x, so it wouldn't be 41.
Oh,
Yes, sir. I thought so.
this one here?
Yeah.
That could be right, because it should be this one, right?
Yes.
Oh, okay, no, because that's that. So 0, but this one also should be different, right?
No.
Yeah, she's right. Okay, Hannah's after all paying attention. So,
Hannah the goat?
Okay, wasn't
good job.
Yeah.
So let's do that. I lost track of what we were doing. Let that be an example to you. So that's going to be 6 times -1, right? So that's going to be -6. And then minus 6 times, that's going to be 1. That's going to be minus 6 plus 5. So that for -1 is going to be rather -4.
7.
How is it negative?
Oh, -7, thank you.
How's it? How?
Because -1 cubed is still -1.
Oh,
That's why you do.
but why is it? But it's not cubed.
The first one it is.
Oh,
it?
but
And 6x
Hold on.
cubed.
oh,
And 6x
but the
cubed is
second
going to
minus
be,
x should be plus 6.
Yes, but okay, so -1 fourth one, so that's minus 6 times 1. It's minus 6. So.
Oh, okay.
and this for 2, this is right here, isn't it?
Oh, yeah.
That's not right? Yeah, because that's going to be 6 times,
Yep.
6 times 8, that's 48 minus 96 plus 5. So 2, this is right. So what do we get for 3/4?
Kylie.
I told you
Oh, guys.
It's gonna be somewhere around,
I think it's gonna be 27.
whoa, matrix A 3x4?
Point, yeah, 0.7, that's what we're doing in Algebra 2.
I think it's gonna be negative 27.
So we have that. So we have 6x cubed minus 6x to the fourth plus 5.
Take your guess, let's see.
You said 27?
6x cubed
Probably like.
minus 6x fourth.
I got a question there.
And was it plus 5?
Yes. Oh.
So yeah, I'm glad we didn't work this out by hand, because I don't know what kind of fraction actually produced this. But you have, what it is, when you have 3/4 to the third power and all that, that's gonna be a lot.
3/4 to the fourth power would be like.
So it'd be approximately 5.633.
256 would be the denominator.
5.633. So what is our answer for maximum and minimum? So absolute
-7, oh wait.
minimum
-3.
Minimum
of -43,
where x equals 2.
where x equals 2.
Maximum would be 5.633.
So absolute max of approximately, that's understood, 5.633,
6.3.
where x equals 3/4. Okay, let's get on the classwork section here, which is going to be, I'm going to go, because sine, we haven't really gone into sine and cosine much yet. We're going to do that soon. Okay, so here we are to this section here that says homework. You see that?
Ugh. You're killing me here.
So why don't you just do 1 and 2 here? Yeah, do 1 and 2 right here.
All right.
Absolute maximum.
Really? For real?
For real, for real?
For real, for real. Stomach?
My stomach went.
I heard.
I worry about myself sometimes, Mr. G.
I think Mr. G worried tonight too.
At least I'm not boring.
No,
I don't think.
you're not that.
What if I was boring? That'd make me cry. 1 minus 2 plus 1
Real?
would be 0.
Is that for the first one? No, that's not.
What? Can you stop, yeah?
Oh, what?
Making those noises, it's
Like that? Keep it in.
I can't wait.
Oh, you little fool.
On what?
Weird noises, weird.
What if we talked in like clicks and stuff rather than jump?
You're talking what?
What I just like. I want to be able to talk like that.
What's that mean?
He knows what it means. Get your You're like at a restaurant, you look across the room and you see a family just going. You make it sound so funny. You know what I mean? Oh. Ooh.
Have you finished number one?
I finished number one.
So you're working on number two? Who, everybody else finished number one, two? Yeah. You know what you're doing here, Carson? Carson wasn't here yesterday, that's why I'm asking.
Negative 4, that would be a negative 5.
Hey, your knees not so wet.
Let me know when you're ready for me to show you the answers,
Negative 2.
because I have the answers.
Minus 3 is negative 5.
I'm lost.
7 minus 1 is 6.
You're lost? How do you get lost?
Step one.
Yep. No, not step one, like step 3, I think.
And what is step three? What's steps 1 and 2?
Make it in the chart and then F1.
Oh, so the arithmetic of the evaluation is what you're saying?
I think so, yeah.
Yeah, so basically, you're gonna go ahead, you know you have two candidates here already, which are 0 and 2. Then we find that next candidate, because we got, what's it gonna be, 8x minus 4?
Yeah.
So that's gonna be 1/2, right?
1/2 what?
This is gonna be a critical number.
Really?
Is that right?
That's why
Oh, see, that's what I was stuck on.
18.
Yeah, because you're gonna get, you
Yeah.
get 2x minus 4
X
equals 0,
1/2.
right? So 2x minus 4 equals 0.
Good now.
So 1/2 is your other candidate.
I need to.
And then you'll just plug in at 0, you have your output of 1, then you gotta plug in 1/2 here,
What's 2x minus 4?
which is gonna be, that's gonna be 1/4, that's gonna be 1,
No.
minus 2 plus 1. Oh, you were, that's what you were talking about, Aaron. 1 minus 2 plus 1,
Mm-hmm.
which is 0, and then you plug in 2, get that, so that would be that. So that one here, I just sort of worked it out almost in my head, I didn't write it down though.
Good job, Mr. G.
Then the 2, I didn't quite finish that, that's gonna be 16 minus 8 plus 1, isn't that 9? Okay, I did.
What was the question?
You should just write it down so I can keep up.
So there was 1, it was like 1, 9, 1, 0, and 9, right? Isn't that right?
That's what I got.
Because minus 2, minus 8, 16 minus 8 plus 1, yeah. So is that what you got for that one? Yeah.
That's what I got. Uno, cero, y nueve.
Right, and so you have your maximum and your minimum right here. So did you do number 2 yet?
I did.
Number two is more one that's harder to do in your head
True.
because you just have more numbers to add. So anyway, I have this all worked out right here. And here it is.
Oh. That's a lot of work. I just didn't know.
Yeah.
So this one here is the same thing, right? We already talked about this one. And this one here, you have these critical numbers of -1 and 2. And then here you have it all worked out. So is that what you got for this thing here?
No.
Yeah.
Don't
Fly
fly
off.
off.
Didn't finish
We're
quite?
gonna break your face.
Okay. So to me, the more challenging part of this is sort of just the arithmetic of substituting. If you do that. Other than that, I don't see this as particularly challenging. And if you really think about this, even though this is part of the calculus course, yeah, I guess it is, because we had to do that take that derivative, right? But otherwise, it's just evaluating.
Oh my goodness, it's -21. Wow.
Hey, Mr. Grove.
Yes.
Okay, you want to hear an interesting paradox question?
Okay, yes.
Okay, so I went back in time and taught Isaac Newton about gravity. Who discovered gravity, me or Isaac Newton?
Whoa.
Well, if he didn't know it before you taught him, I guess you did.
But I only knew it because he knew it.
Oh, I see what you're saying. I did some study about Isaac Newton just last weekend that's just coincidental to that. What happened is Isaac Newton, when he was a grade school kid, he was bullied. And
I feel that.
what he did is that as retaliation for his bullying, he decided to retaliate by really amping up his success in school, about just working hard and learning all this stuff. And so it was overcoming the bullying that sort of got him in a direction of, hey, trying to achieve. So that was his initial motivation as a grade school kid. And then he went away to college in 1665, there was a bubonic plague that hit England, killed over 100,000 people. And you know what happened during that plague? What they did to Cambridge University where he was going? They shut down the school. So he went home. So during an epidemic, he goes back to home, and what does he do when he's at home?
Discovered gravity.
He discovered the principles about gravity, optics, motion, and calculus.
He discovered calculus?
Yeah, he's one of the
I'll go back and tell me.
he's one of the reputed discoverers. There was Leibniz too, who discovered it probably after Newton did, but actually the notation that we use in calculus is more Leibniz's, because Leibniz came out with it first. But anyway, another thing that happened it was in 1666, half the city of London burned down too. So it was like a terrible year, but it ended up being a great year because it was with the discovery of calculus and all the other stuff Newton discovered that sort of ushered in
Definitely terrible.
the industrial age, which led to the age of technology that we are in. So really, so you can kind of look back, it was during an epidemic. I mean, we're dealing with an epidemic right now where we were sent home. What did I do when we were home? Nothing like invent that kind of stuff, but I thought that was pretty interesting. Okay.
Remember when Kobe died and you were like, how could this year get any worse?
Yeah, right. Oh, yeah. Be careful what you wish. Watch this, yeah.
Hold my beer.
So we already did this one. Anyway, I think we'll be good with that. Yeah, we're having these fractional things here.
Let's do 7.
Let's look at 7.
Yeah.
No, we're not going to do
Let's
7.
do that.
But here, yeah, okay, we will do 7.
Gavin,
No, that's fine.
Like 5 minutes.
could have show?
No, because I want to show that it can be done. It's really a pretty easy one. We're
It's
going
an easy
to,
one.
okay, we have our endpoints, so we're going to do a candidate test here. We have x and f of x, and what are the candidates here? Negative pi over 4
Negative pi over
and pi over 4, right?
4. And, those are not known.
And then we're going to need to do what for this? Find the critical number, right?
Yeah.
So what is f prime of x?
That's going to be 1 minus,
It's going to be 1 minus, it's going to be secant squared x.
yes.
That's going to be the derivative. And secant squared is 1 over cosine squared x. That's what secant is, so 1 minus that. And so we set that equal to 0. We have 1 equals 1 over cosine squared x. And we cross multiply that. We have cosine squared x is equal to 1.
Whoa.
And which occurs, and cosine x is 1 where? At x, between negative, at pi equals 0, right?
X equals.
At 0, at x equals 0, right? Because cosine of 0 is 1. So that's the only place. Now, it could be also negative 1, or negative 108, whatever, or pi on the other side could also be. But these are the critical numbers right here. And so we can just plug in this. Well, we'd have at pi over 4, well, at x equals negative pi over 4, we plug in that, we're going to get negative pi over 4. And tangent of negative pi over 4 is what? Negative 1.
Yeah. Nailed it.
Nailed it.
So that's going to be negative pi over 4 plus 1. And then at 0, we would have tangent of 0, which is 0. And then here we would have pi over 4, we'd have positive pi over 4 minus 1. So that's going to be positive pi over 4 minus 1. And which one of these is bigger than the other ones? Because it's going to be
That one.
negative pi over 4. What's negative pi over 4? It's going to be 3.4 divided by 4. Or so let's say 3 divided by 4. That would be negative 3/4 plus 1.
Yeah, that's bigger.
So this would be bigger right here. So here's so this is going to be
Your max.
your maximum, and this is going to be your minimum. So, well, you could do that, and you can get more familiar with these. It's actually the derivative thing we haven't done yet in this class. Everything else.
Yeah.
So that's that one.